So practice 10 through 16. I'm going to let you work on those on your own. Sketch a graph that satisfies the given conditions. We're going to do that one together. Yeah. I'll leave myself an entire sheet of paper for 10, 12, 14, and 16. Number 24, I want to sketch a graph that has the first derivative less than 0 and the second derivative less than 0 for all x. So, first derivative is less than 0. Means it's always decreasing. The second derivative, less than 0, means it's always concave down. So I need something that's always decreasing and concave down. You notice both of those are negative, so it's decreasing at an increasing rate. It looks like that. So it's decreasing, and it's decreasing faster and faster and faster as time goes by. Part B wants the first derivative to be positive and the second derivative to be positive. Increasing at an increasing rate. Increasing, concave up. So it's always increasing, and it's increasing faster and faster and faster. Easy enough. Let's see if number 28 is a little more fun. We want the first derivative to be greater than 0 everywhere except at 1. So I'm going to make a sign chart, and I'll put 1 on it. F primed is positive everywhere except at 1. Second derivative is greater than 0 if x is less than 1. Or if x is greater than 3. So I need to add a 3 to my sign chart. Now, first derivative is always positive. And it's negative if we're between. So we're always increasing, concave up, increasing, concave down, increasing, concave up. And it says we have a vertical asymptote at 1. There's my dashy line for vertical asymptote. So we are increasing concave up. Doesn't say anything else, so increasing concave up. Increasing concave down from 1 to 3. So from 1 to 3, I need to be concave down and increasing. And then at 3, and put it right there, I'm going to switch to concave up. Something like that. Yours could be slightly different, but it has to satisfy all of those things. Okay, we have a little more interesting graph to draw. So let's see what we can do with this one. Example 7. So first thing I would look at is where it crosses the x-axis, because it's really easy to figure those out. It's going to cross the axis at 0 and at 6. So I'm going to plot 0 and 2, 3, 4, 5, 6. Then we'll take the derivative. I'm going to take the first and second derivatives and set them equal to 0, and I'll meet you back here in a minute. I am glad I didn't make you watch me find those derivatives. They were ugly. I bet you gave up and put them into Symbolab. I should have. So first derivative, product rule, first d second, second d first. Came out with 2 pieces. Common denominator. Combined. It looks kind of friendly, not too bad. Set this thing equal to 0. It's going to be equal to 0 only when the numerator is equal to 0. So when x is equal to 4. And f primed does not exist when x is equal to 6 and when x is equal to 0, because that puts zeros in the denominator. So those will be on my sign chart over here, 0 and 6. And 4, excuse me, I left off the 4. I didn't leave it off. 0, 4, and 6. Then it took me a whole stinking page to do the second derivative. I will post this and you can look at it and see that it is amazing that I made it through this with no algebra errors. But low D high, less high D low. Within the low D high, high D low, I had to do a product rule, first D second plus second D first. I ended up with a fraction on top of a fraction, which offended me, so I multiplied by the denominator to get rid of it, and somehow I just ended up with a -8 on the top. So the second derivative will never, no not ever, be equal to 0 because the numerator will not be equal to 0. So then I did some plugging and chugging to figure out that we are decreasing for numbers less than 0. We're increasing for x values from 0 to 4, and then decreasing after that. Decreasing, decreasing, decrease. Well, negative, 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 concave down, concave up. I plugged 4 in so I could plot my local max there at 4. And I got a graph that looked something like that, and I was very pleased because it looks a lot like that one in the book. And now I am done. Drop the pencil. It is definitely happy hour. Go forth and do your web assignment.